Current electricity, problem number 1. In a conductor, if number of conduction electrons per unit volume are 8.5 and mean free time that is 25 femtoseconds and approximate resistivity. Remember students, they are not asking exact resistivity, approximate resistivity. So in most of the competitive exams, we need to give the approximate values only because we cannot use the calculator. So resistivity is given by mass of electron by n into E square tau. What is the mass of electron given? This is 9.1 into 10 power minus 31 by. The number of electrons per unit volume is given by 8.5 into 10 power 28. And the charge of electron, which is not given here, but we know this value, 1.6 into 10 power minus 19 whole square. And the time, that free time is 25 femto, that is 10 power minus 15. Now you can see this 9.1 by, this is 8.5, this is 1.6 whole square. So 1.6 into 1.6, this is 2.56 into 25. So other terms are 10 powers only. This is 10 power minus 31. This is plus 28 will become minus 28. This is minus 19 whole square will be minus 38 when this goes up plus 38. And this will be minus 15 will become plus 15. You can see this is 38 minus 28 is 10. 10 plus 15, 25. 25 minus 31 is 10 power minus 6. So 9.1 into 10 power minus 6 by, this will be 8.5. This is 2.56. I require the approximate value 2.56. I am taking it as 2.5. So this will be 10 by 4. 10 by 4 is 2.5 into 25. Now you can see this 9.1 and 8.5 nearly equal. Let me take it as nearly 1. So this will be 4 by, this is 250 into 10 power minus 6. I should not take it as equal. This is nearly equal to. Now this is 4 1 so 4 6 24 10 62.5. 1 by 6 is 0.16. 1 by 62 will be 0.16. So 0.016 into 10 power minus 6. So you can write this as 1.6 into 10 power minus 8. So they are asking only the order. So option 4 is correct. Number 2. In hydrogen atom, an electron makes 6 in 10 power 15 revolutions per second around the nucleus. Its equivalent current. So in hydrogen atom, electron is revolving like this. So what is the current? Current I is equal to Q by T. Q is equal to, from quantum structure, NE by T. So here n is the number of revolutions per second. It is given 6 in 10 power 15 revolutions. So this is 6 into 10 power 15 per second into charge of electron 1.6 into 10 power minus 19. 1.6 into 6 will be 9.6 into 10 power minus 4. So here this is a 0.96 into 10 power minus 3 ampere. First option is correct. Third one, the resistance of a wire is 90 ohms. The resistance of another wire of same material, when the material is same, resistance would be same, having double the length and twice the radius. We know resistance of this any wire is given by rho L by A, which you can write as rho L by pi r square. So here R1 by R2 is equal rho 1 L1 by pi R1 square into pi R2 square by rho 2 L2. As these are same material, this and this get cancels. Pi and pi also get cancelled. This will become L1 by L2 into R2 by R1 whole square. Initial length is L, which is not given, but a second wire is having double the length of the first one. So this is 2L into, and the radius is thrice the radius of this one, cross sectional area. Now this is a 3R by R whole square. This get cancelled, L get cancelled. This will become 1 by 2, 9. So this is R1 is given as 90 ohms by R2. So this is a 9 by 2. 9 ones and 9 tens. So R2 will be 20 ohms. Option 3 is correct. Fourth one, a wire of resistance 5 ohm is drawn until its length is doubled. What is the new resistance? So let me take the same formula. R is equal to rho L by A. Multiply with L and divide with L will become rho L square by V, where V is the volume of the wire. if the wire is stretched to double to its length, its radius decreases, length increases, but volume never changes. So here rho is a constant, volume is constant, therefore R directly proportional to L square. So you can write R1 by R2 is equal L1 by L2 whole square. Initially wire of resistance 5 ohms and the second resistance we need to find. Initial length was L and final length was 2L whole square. So this is 1 by 4. R2 is equal to 20 ohms. So option 3 is correct. Fifth one, if a wire is stretched to make 0.5% longer, so initial wire is this one, and if it is made only this length increased is less than 1%, now the percentage change in its resistance is, we know from the previous problem, R directly proportional to L square, we can write R is equal to K into L square. Now differentiate this one, what you will get? Delta R is equal to K into L square is 2L into delta L. Now divide this with R on both sides. This is R, this is R. So this is delta R by R into 100. If you multiply with 100, this will be K into 2L into delta L by, what is R here? This is K L square into 100. You can cancel this K and K. You can cancel one of the L here. So what is the percentage change in resistance when the length increases by some percentage? So this is 2 constant delta L by L into 100. So this is 2 into, what is the percentage change in length? In this problem this is 0.5. So this is 0.5%. So answer is 1%. Remember students, you can use this method only if the percentage change in length is less than 1%, or in some cases you can take it as up to 2%. Next one, a piece of wire 8 ohms is bent into 180 degrees at midpoint and 2 halves are twisted together. This is a wire. At the midpoint it is bent into 180 degrees, means like this, and these two are twisted together. What is the resistance of this one? Resistance of this wire, actual wire is 8 ohms. If it is bent, this will become 4 and 4. Now the resistance of this wire is, so these are said to be in parallel. So in parallel combination, RP is equal R1 R2 by R1 plus R2, that is 4 into 4 by 4 plus 4, that is 16 by 8. So this will be 2 ohms. Option 3 is correct. If the temperature quotient of resistance is, this is alpha, which is given by 0.0125 per degree Celsius, then the temperature at which resistance of the wire will be thrice that of its resistance at 0 degrees. We know this formula, alpha is equal to resistance at high temperature minus resistance at 0 degrees by R0 into T minus 0. So I am going to use this formula here, alpha. So here resistance at high temperature is thrice the resistance at 0 degrees. So alpha will be 3R0 minus R0 by R0 into T, that is 2R0 by R0 into T. R0 R get cancelled. So temperature will be 2 by alpha. This will interchange this one. So this is 2 by, what is alpha? 0.0125. You can write this as 125 into 1, 2, 3, 4, 10 power minus 4. So this temperature is 2 into 10 power 4 by 125. So you can write 2 into 10,000 by 125. So this will be 25 5s, 25 4s, 100, 0, 0, 5 1s, 5 8s, 5 8s and 5 zeros. So this temperature will be 160 degrees Celsius. Option 1 is correct. 2 ohms, 3 ohms, 5 ohms are connected in series across 10 volts battery. So this is 2 ohms, this is 3 ohms, and this is 5 ohms connected across a battery of 10 volts. Now, with the negligible internal resistance, the potential drop across the 3 ohms, I need to find out the potential drop across this one. Just like in capacitors, in resistors also, in series combination, the charge remains same. That is, charge through first one is equal to charge through second one is equal to charge through third one is equal to the net charge. But here we are going to find out the charge per unit time. That is, I1 is equal to I2 is equal to I3 is equal to capital I. I want to find out the potential across the second one, so let me take only these two. I is given by V2 by R2 is equal total potential by total resistance of this series combination. So what is V2? V2 is equal the net potential or the total potential applied into the resistance of the second resistor by sum of these three resistors as these three are connected in series. So what is the applied voltage here? 10 volts. Resistor in the second circuit, this is 3 ohms by sum of these three resistors 5, 6, 7, 8, 9, 10. This is 10. So this will be 3 volts. Option 2 is correct. A wire of resistance 12 ohms is bent in the form of an equal triangle. So this is an equal triangle, and this equal triangle is formed by a wire whose total resistance is 12. As equal triangle has 3 similar sides, each side will be, this will be 4 ohms, 4 ohms, 4 ohms. Together it is 12 ohms. The effective resistance between any two corners of the triangle. So let me take this point as A, this point as B. Now I want to find out potential resistance between these 2 points. These two are in series, and for this is parallel. So effective resistance between RAB is equal, this is R1, and let me take this as R2, R1 R2 by R1 plus R2. What is R1? 4 plus 4, this is 8. R2 is 4 by 8 plus 4 is 12. 4 3s, option 8 by 3. Option 4 is correct. 12 resistors, each of 12 ohms, so is connected to form a sides of a cube. So this is a cube, and these are the 12 sides. Each side has 12 ohms resistance. So this we call it as skeleton cube. The equal resistance across the diagonal between this point and opposite diagonal this point. So in this we have a direct formula. The equal resistance of a skeleton cube is 5 by 6 times the resistance of each one. So 5 by 6 into R is equal to 1262. This is 10 ohms. Option 4 is correct. And the equivalent resistance between A and B. So this is point A, point B. You can see this one, this is 8, this is 16, this is 16. This is 20 ohms, this is 9 ohms, this is 18 ohms, this is 6 ohms. Now, these three are in parallel. So, first of all, for this combination, 16 and 16 are parallel. If similar resistor connected in parallel, the effective resistance is half of it. That is 16 and 16 together will get 8. And now 8 and 8 are parallel. So, this will be 4. Now, similarly, this is 9 and 18. 9 into 18 by 9 plus 18 is 27. 9 1 so 9 3 so this is 6. Now let me draw the same diagram here. This is 4, this is 20, this is 6, and this is also 6. Now 6 and 6 are in series, this will become 12. 20 and 4 are in series, this is 24. Now these two are in parallel. 24 into 12 by 24 plus 12 is 36, 12 ones, 12 threes. So this is 8 ohms. Option 2 is correct. The equivalent resistance between A and B. You can see this one. This is A, this is B. If you observe this one, some students may think that these three are connected in series. No. Here, let me take this point as C, this point as D. So between A and C, first resistor is connected. So this is A. So this is C. Now between C and D, one more resistor is connected, but point A and D connected without any resistor. That means point A and D are similar points. So between C and D, one more resistor is connected. Between D and B, one more resistor is connected. Whereas C and B connected with this wire. So B and C are similar points. Now between D and B. So now these three are connected in parallel. In parallel combination, this resistance, equivalent resistance will be R by 3. Option 3 is correct. 10 cells each of EMF 2 and internal resistance 2 are connected in series. 3 of them wrongly connected in the net EMF and internal resistance of the combination is. So when 10 cells are there, in that combination 3 are connected wrong. If one is connected wrong, 2 cells will be cancelled with each other. Why? Because if it is connected like this is E, this is E, net EMF will be 2E. If it is connected like this, that means this here negative to positive, then it will be E plus E 2E, but here negative to negative, so this will be 0. That means if one of them is connected wrongly, two cells will be cancelled with each other. Now here, out of 10, 3 are connected wrong, so 3 into 2, 6 cells will be ineffective. So the total net effective EMF is given by E net is equal 10 minus 2 into 3 into this EMF E. That is 10 minus means 4E only. 4 into E is equal to 2. This is 8 volts. This is net EMF. But resistance cannot be negative. So each resistance is 2 ohms. There are 10 into 2, 20. So option 3 is correct. 14. Two cells of same EMF are in series with an external resistance capital R. So these are two cells which are connected in series and they are in connection with the external resistance capital R. The internal resistance of R1 is greater than R2. So let us say this is R1, this is R2, R1 greater than R2. The PD across the first cell is found to be 0. So let us say the PD across this one, V is equal to 0. Then the value of capital R is question mark. Now here in this case, if I want to find out the potential here, when it is discharging, V is equal to E minus IR. To find out this one, I need this as well as this. But here in this case, both are having same EMF. That is, EMF of this one is E, EMF of this one is also E. Now, what is the total current flowing through this circuit? Total current I is equal to E plus E, net EMF by R1 plus R2 plus capital R. This is the effective resistance. So this is we can write 2E by R1 plus R2 plus capital R. Now let me take this equation, V is equal to E minus IR1 for the first cell. V is 0, E is equal to E minus I is equal to this much, that is 2E by R1 plus R2 plus R into R1. This minus this 0 means these two values must be equal. So E is equal to 2E R1 by R1 plus R2 plus capital R. This E and E get cancelled. This will become R1 plus R2 plus capital R is equal to 2R1. We need to find out capital R value. So capital R is equal to 2R1 minus R1 minus R2. That is nothing but R1 minus R2. This is R1 minus R2. So the correct option is 2. 15. In the figure, the PD across the cells E1, E2 are respectively. Here you can see two cells. In general, when cells are connected in series, the positive terminal of a cell is connected to negative terminal of the other cell. But here, positive and positive connected together. So one of the cell will give or will discharge the current, the other one will receive the current here. Here if you observe this one, the second cell is having 8 volts, the first cell is having 4 volts. Always the bigger cell will discharge here. So current will be coming from this positive terminal in this direction I. So here it is discharging and this cell will be charged by that current. So in this case, what I am going to find, so let me redraw this diagram. This is a first cell, this is a second cell, and these two are connected to 4.5. Here 3 and 6, here 3 ohms and 6 ohms are in parallel. So effective resistance of this one, 3 into 6 by 3 plus 6 is 9, 3 is, so this is 2 ohms. So here 4.5, instead of 2 resistors, I am going to keep only 1 ohm, 2 ohms resistance here. So like this, so this is 1 ohm, this is 0.5 ohm, and the EMF is, this is 4 volts, this is 8 volts. So what is the amount of current passing through this circuit? The amount of current, total current is given by E1 plus E2. Let me take this as E1 and it is given as E1. This is E2 and this is given as E1. So this will be R1 and R2. So this will be total EMF E1 plus E2 by total resistance R1 plus R2. This is R1 plus R2. Let us say this is R3, this is R4. So R3 plus R4. So total net EMF in this circuit is given by 8 plus 4. But we cannot write 8 plus 4 as this is 8 volts, this is 4 volts. So there is this discharging, this is this one. So when positive and positive connected together, we need to write E1 minus E2, not E1 plus E2. So this will be 8 minus 4 by R1 plus R2, that is 0.5 plus 1 plus, this is 4.5 plus this is 2 ohms. So the current is given by 4 by 4.5 plus, this is 5, 6, 7, 8. So the current passing through this circuit is half ampere. So when a half ampere current is passing through this one, what is the PD across the first and second cell? So this is the first cell. So here current is entering into this one, that is this cell is being charged by some current. So when the cell is charged, we can write V is equal to E plus IR, where E is equal to 4 volts plus I is equal to half, and resistance here is also half. So this will be 4 plus 1 by 4, so 4.25 volts. This is the voltage across the first one. Now second one, as it is discharging, the potential across the second cell will be E2 minus IR2. So this is 8 minus, current is half and resistance is 1. So 8 minus half, 7.5 volts. Option 2 is correct. 16. 4 cells each of EMF 1.5 and internal resistance 2 used to send current through a 2 ohm resistance. If cells are arranged in series, what is that current? So here 4 cells are connected in series, all are similar cells and connected to external resistance of 2 ohms. This internal resistance is also 2 ohms, 2 ohms, 2 ohms and 2 ohms. And this is 1.5, 1.5, 1.5, 1.5. So what is the total current through the circuit? Total current is equal to E plus E plus E plus E net EMF by resistance R1 plus R2 plus R3 plus R4 plus capital. This is E1, E2, E3, E4. But as these are 4 cells of similar EMF and same internal resistance, we can write 1.5, 1.5, 1.5, 1.5, that is 6 volts by R1 plus R2 plus R3 plus R4. This is 2, 2, 2, 2. This is also 2. So this will be 10. So this will be 0.6 amperes. First option is correct. To get a maximum current in external resistance of 8 ohms, one can use M rows and N cells. So in each row we have N cells each. And how many rows are there? There are this is mth row. If total number of cells are 64, each are having EMF 2 volts, internal resistance 2 ohms. So this is 2 volts comma 2 ohms. To get the maximum current through this one, so maximum current is given, first of all current is given by total number of cells. N cells are there in each row, in one row. So E plus E plus E plus, this is will be NE. As this is NG, total EMF, this will be NG, NG, NG. So total EMF will be NG only. Then, what is the resistance in this branch? Each resistance, let us say small r, this is NR by, as there are M rows, M plus capital R, where capital R is the total external resistance. And this is given as 8 ohms, R is equal to 8. So for this current to be maximum, this value, the denominator should be minimum here. So for this to be minimum, we can say this plus this must be same. So we have this formula NR by M, that is the net internal resistance of this circuit must be equal to the external resistance. So we know this value N by M into R is internal resistance of each cell, which is given as 2 ohms. This is 2 is equal to 8 to 4. So N is equal to 4M. But the total number of cells in this circuit is 64. That is N into M is equal to 64. So in place of M, N, you can write 64 by M. So this you can write n is equal to 64 by m is equal to 4m. 4 ones are 4, 6, 24. So 4, 30, 16. So m square will be 16. M is equal to plus or minus 4, but I will take only the positive value. So here I got m is equal to 4. Now you can check m16, m8, m32, m4. So option 2 is correct, as the multiplication of these two, 16 into 4 will be 64. In the figure, the reading of ammeter is, so here we have ammeter. What is the amount of current passing through this one? First of all, let me find out the main current. The main current I is given by the EMF of the cell by the total resistance of this circuit. Here 20 ohms and 40 ohms. This is 20, this is 40. Connected in parallel. So 20 into 40 by 20 plus 40 is 60. 21 so 23. So this will be 40 by 3. But this is given as 20 by 3. So what is the net resistance here? So here net resistance is, here we have 8 ohms. Here this is 20 by 3, this is 40 by 3. So this I will write 20 by 3 plus 40 by 3. So this is 20 plus 40, 60 by 3. 60 by 3 means 20. So net EMF is 28 by 20 plus 8, 28. So the main current is 1. But I don't want the main current. Here I want to find out the current passing through this ammeter. So to find out the branch current here, whatever the current that is coming from the cell, that is 1 ampere will pass through this one. Here it will divide into 2 parts. So what is the amount of current passing through this 40 ohms? So current through ammeter, that is I40, is given by main current into resistance in the other branch by sum of the two resistors. This is the branch current formula. So you can write here 1 into resistance in the other branch is 20 by sum of the resistors 20 plus 40. So this is 20 by 16 or 1 by 3. Option 2 is correct. 19. In a meter bridge, if the left and right gap resistors are in the ratio of 4:6, then the balance length is given by. In a meter bridge, the unknown resistance by resistance in the right gap is given by the balance length by 1 minus L if they gave these options in meters, and as these are in centimeters, so we need to write this as 100 minus L. So what are the ratio of resistors in this one? This is 4:6. So let me take this as 4:6 is equal to L by 100 minus L. 2 2s, 2 3s. 3L is equal to 200 minus 2L. So this is 5L is equal to 200. L is equal to 40 centimeter. Option 1 is correct. Similar problem, when a 2 ohm resistor is connected in the left gap of a meter bridge, balance length is found to be 40. Then the resistance in the right gap. So that is X by R is equal to L by 100 minus L. Now a 2 ohm resistor is connected in left gap. This is 2 ohms. Resistance right gap is unknown. This is 40 by, this is 100 minus 40. That is 40 by 60 or 2 by 3. So R should be 3 ohms. This problem, a similar model will be given if resistance R is R1 here and R2 here. These are the left gap resistors, and the right gap resistance generally we take it as R. Let the balance length is L1 and remaining length will be 100 minus L1. For this combination, if one more resistance is connected in parallel, let us say R3, so what happens to this balance length? As these two are connected in parallel, the effective resistance of this part will decrease. As this resistance decreases, the balance length also decreases. This is a theory based question, but by using the concept. So this is also very important. In some problems, instead of connecting resistance in the left gap, let us say only one resistance is given R1 and no resistance is connected in right gap. If one more resistance is connected either in series or in parallel, then also the resistance in this right gap will decrease if they are connected in parallel, increase if they are connected in series. So this is also another important model, but the formula remains to be X by R is equal to L1 by 100 minus L. But we have to calculate the effective resistance either in the right gap if something is connected in series or parallel. Sometimes they may give resistance in the left gap, so that means they may connect resistance in the left gap either in series or in parallel. Then we have to connect this value. So based on this one, different models can be given. One, when a 1.5 volt cell is connected in the secondary circuit of a potentiometer, balance length is found to be 2 meters. If 3 ohm cell is connected in the secondary circuit, what is the balance length? For potential meter, the ratio of the potential EMFs are equal to the ratio of the balance lengths. In the first part, 1.5 volts is connected and the balance length is found to be 2 meter. If 3 volts is connected, what is the balance length? So this is 112, this will be L2 will be 4 meter. Option 4 is correct. 22. This is one of the most important model in current density based on potentiometer. Here we are finding the internal resistance of a cell. The formula is initial length by next length balance length. This is initial balance length by final balance length minus 1 into Kepler. What is L1? L1 is the balance length without external resistance. L2 is the balance length with external resistance, and Kepler is the resistance that is connected here. In this circuit problem, a cell is in the secondary circuit gives a null deflection for 2.5 meter, that is L1, of a potentiometer of length. The total length is 10 meters. Now the balance length is 2.5 and second time the balance length is 2 meters only. Whenever the external resistance is connected, the potential difference will give less balance length. So into R. Remember, this is the balance length for EMF of the cell. This is the balance length for PD of the cell. That's why we know that EMF is greater than PD. So EMF will give more balance length and PD will give less balance length. So this will be the formula. So this will be 1.25 minus 1 into R is equal to 4. 0.25 into 4. This is 1 by 4 into 4. So this is 1 ohm. Option 2 is correct. 23. After seeing this circuit, some students are not solving this problem. Why? Because some students are very weak in applying Kirchhoff's voltage law. But this problem, as we know, there are no cells. So this is only Kirchhoff current law. Very simple problem. So this is based on Kirchhoff current law but not on Kirchhoff voltage law. In the given circuit diagram, the currents are 0.3. So this is minus 0.3. That means here arrow is shown downwards, but actual current is going up. Then I4 is equal to 0.8. So this is 0.8. And I5 is equal to 0.4. So this is 0.4. Now the currents I2, I3, I6 are how much? Now here, by applying Kirchhoff current law at this junction S, the incoming current is 0.8. This and this are outgoing currents. Out of 0.8, 0.4 is going in this direction. It must be 0.4. So this value I3 must be 0.4. So this is I3. This is I1. This is I2, I3. This is I4, I5. This is I6. So now I got this value I3 as 0.4. So this is 0.4 amperes. Next, here you can see this 0.5 amperes current is going here and it's going in this direction. So there are no other junctions here. There is no other paths for this current to flow. So this must be 0.4 only, because this current is not going anywhere. This is current. This current is going in this path only. So this is 0.4. This is 0.4. Once again, the current at Q will be 0.8. So now I got I6 as 0.4 only. Now this 0.4. Here I3 is minus 0.3. That means current is going up 0.3. So this 0.3 will come here. 0.4, 0.8 plus 0.3. So this will be 1.1 ampere. So the current here 1.1. So I2 will be 1.1. So what are the currents in I3, I2, I3, I6? This is 1.1, 0.4 and 0.4. First option is correct.